Dear students, actually we are on the discussion of module 3. In the first video we have discussed about the method study and what are the basic procedure in method study and what are the different process charts which are commonly used in industry for method study, like outline process chart or operation process chart, flow process chart, two-handed process chart. Today, as a continuation of first part, we are moving to the next topic called different diagrams used for recording. As we know that different charts we are discussed in the used in method study are operation chart, flow process chart, or two-handed process chart. Whatever the chart it may be, it gives the sequence and nature of movement of the material, but it does not give any clarity about the path and where the department is, how much the distance it have been moved, the location of department, etc. So for that purpose, usually diagrams are used. Diagrams give pictorial view of the layout of the workpiece, the location of different equipments, machines, etc. by indicating. So we can know the movement of material, either man or machine is indicated by in a diagram, either through a line or a string. So the diagrams are very valuable, or its major advantage of diagrams are we can easily understand that how the materials are moving, how much distance, and where the departments are located. So if you want to be understand that if two or three departments are clubbed together, is there any possibility to increase the value, or we can reduce the non-value added process. There are different type of diagrams are there which commonly used in industries. Major types of flow diagram, string diagram, travel chart is there, cyclograph is there, and other charts are there. Today we will discuss, in this part we will discuss the major two diagrams. I already uploaded the detailed note of module 3 and also the detailed question and session of module 3. In the details and notes are there in detailed question and answer, important question and answers. All these notes are there, so you can easily verify it. So today in this lecture we will basically look into flow diagram as well as string diagram. So what is a flow diagram? Basically, as shown in the figure, flow diagram will give you a top view of the work area, or it's shown basically it will give a picture representation where the machines are located, and from a material is moving from one station to another, the how much distance it has been moved, is there any movement is there or backtracking is there, that type of information usually we will get from flow diagram. Basically it's a diagram drawing which is drawn into scale. So basically it shows relative production machinery, jobs, fixtures, etc. And it's also give the mark, the path it moves, as shown in the figure. From the raw material store it moves to raw material, then it's go up to forge shop, then it's go up to machine shop, then milling, heat treatment section, two-way, and finally inspection and storage. So we will get a clear idea that how much distance it has been moved. So this will be a base commonly used diagram in one of the diagram is used in industry, that is flow diagram. Okay, so another type of diagram which commonly used in industry is string diagram. A string diagram is a scale plane or a model in which a thread is used to trace and measure the path of workers, material or equipment during specified sequence of events. If we are connected the movement of a material using a thread, the string diagram will be like that. So we will get a clear idea that how much movement is there. The major advantage of string diagram over flow diagram is, in flow diagram repetitive movements cannot be tracked, but in string diagram we can track the repetitive movement of machines. We will get a clear idea that how much backtracking is there. If a material is moving from M to M1 to M2, then M3, M4, so we will connect the items, and we will also you'll get a clear picture idea that is the how much distance it has to be traveled and another other details. So when there is a too much movement involved, the a string diagram is used more than a flow diagram. So basically string diagram is also drawn to scale, almost equal to scale. So this is another commonly used diagram in industry. So this will be the first part, method study and the charts and diagrams used in method study. We will be moving to another area in the module 3, that is micro motion study. From the name itself, it's give an idea, micro motion study. Actually, we will divide the motion, we will divide the work into small components, and we will try to find the in-depth details of each component. Usually micro motion study is a study of fundamental element. Actually we will divide the entire work into small sub elements or subdivision, and usually we will find that we will try to find that each element or each subdivision is necessary or not. Basically micro motion study is conducted using a camera. We will capture all the motions we are doing, and we will divide the entire motion into small subcomponents or element, and we will try to study the usage of each subcomponent. Okay, that will be the micro motion study. So micro motion study provides a valuable technique for making minute details of operation that are short in cycle, contain rapid movement, and involve high production over a long period of time. Usually sewing of a garment, assembly of small parts, etc. connected. That way of motions are studied using a micro motion study. While we are studying micro motion study, the important term you have to be know is turbulences. Actually, while the initial industrial engineering classes, we already discussed the term turbulence. I introduced a scientist called Frank B. Gilbert, one of the pioneer in industrial engineering, who have given different contributions, a huge number of who conducted huge number of studies in work study, method studies, time study, etc. One of the greatest scientists ever, Frank B. Gilbert. Actually, Gilbert is the one who done the major studies in micro motion. Actually, he divided the different motions into 17. Initially it was 17, now it's called 18 small subsections. Gilbert says that every action can be divided from different sub-assemblies of small element. So it can be given us 17 basic motion. It was while initial days it was 17, now it's 18 basic motions. That 18 basic motions are usually called turbulences. While looking turbulences, you can say that it's a backward spelling of Gilbert, turbulence. So each turbulence is represented by a symbol, a definite color, or with a word of a single letter or a two letter. So what are the 18 turbulences? So these are the 18 turbulence chart. So this is the first one, search. First an activity, we can know that first activity, search, usually is denoted by a color black, and this is the symbol for search. Find, color is gray, this is the symbol. Select, grasp, hold. For each motion there is a unique color is there, use a unique symbol is there. So we can denote the entire motion into the small component like that. If I give a simple example, a person is going to take a notebook from a table. So first motion is searching through his eye, search, then he's finding, then he's moving, like as it's called, is moving, then is holding, gripping, like that. That taking a book from a table can be divided into small subsections. So if we spending more time for searching a book where the book is, we need to reduce the time for searching by proper arrangement of books in the table or something like that. So like that we can have a chance of improvement in every motion or every work we are taken for study. If another example can be, if a worker is placing a finished assembled a component into a tray, the first can be, he will take the that finished good part, then he is searching where it has to be placed, then he's placing. So if you want to be small component, we will find that he is spending more time for searching where it has to be placed. So if we are come with a new set of idea for reduce the time for searching, we can have an improvement. Like that, we through micro motion study, we can increase the productivity of the industry by decreasing the non-value added activities. Hope it's clear. That is micro motion study, and that is why turbling is the most important term we need to know while we are discussing the term micro motion study. Another part we are going to study is the principle of motion economy. That's motion economy. Actually, two terms are the motion as well as economy. You don't want to be confused with any financial terms here. You just want to understand the concept that if you are doing an operation, if you are doing a job in a proper way, the best standard possible manner, it will increase the productivity, it will increase the economic dimension of the industry. That will be the best simple explanation of principle of motion economy. Here we are trying to do the best method of doing a job by consuming minimum time, by consuming minimum energy, how we can do a job. If you are try to do a job like with the minimum time and energy in a best possible way, we can increase the productivity by improving the economic dimension of the motion. So here also Gilbert is one of the most important person who contributed to motion economy. So basically there are three principles how we can apply the principles of motion economy in a practical way. These are practical suggestions. One, principle of motion economy applied to physical movements. By optimizing the physical movement of a worker, how we can increase the motion economy. That will be the point of interest. The first point, we will try to reduce the operator movement as much as possible. We will try to have operator movement should be natural, easy, simultaneous and systematical and rhythmical and habitual way. So we will try to have a best way of doing workers' job. So that will be the first dimension of principle of motion economy. Similar way, principle of motion economy also can be applied to the arrangement of workplace. There should be a definite place for all tools and materials. If a definite place is there for all tools and materials, there's not much time we are spending for searching a material or a tool. So like that, by a proper arrangement in the workplace, we can increase the we can apply the principle of motion economy. Third can be principle of motion economy applied to the design of tools, containers and equipments. As we know that by proper arrangement design of a tool, if a tool is designed for a specific job, surely says that will increase the productivity. Without like that, if a tool, there are two types of tools are there, as you know that, a special purpose tool and a generalized tool. Of course, a generalized tool can be general tool can be a many disadvantages, like it may not be suitable for it is not 100% suitable for that specific job, but a specially designed tool can be 100% suitable for that specific job. So like that we can increase the motion economy. So these are the terms we need to know while we are discussing the motion economy. So In this lecture, we have discussed two concepts. One is the different diagrams used in method study, and second part we discussed about the motion economy and what is Veblen's and what are the basic principles of motion economy. Hope is clear. So we have covered the two parts in module 3. Next part we will continue this discussion by discussing the third part, time study. Thank you.